a static performance analysis of hallucination detection algorithm for large language models. What is hallucination model? Hallucination model is like ChatGPT, have shown impressive capabilities in understanding and generate human language. However, this model can sometimes produce hallucinations, which are a response that sounds confusing but contains incorrect or misleading or unverified information. This issue becomes especially important when AI is used in critical fields such as healthcare, law, education, where inaccurate information may lead to serious consequences. Therefore, our study analyze and compress several hallucination detection approaches to identify which method perform the most reliable. The main problem I have to address in this research is that hallucination remains a significant challenge in large language model. AI-generated response may appear factual and trustworthy even when they are actually incorrect. Although many hallucination detection method has been proposed, their performance often varies depending on the dataset and evaluation condition. As a result, it is still unclear which approach consistently provide the best detection performance across different scenarios.
Alright, so next is objective. So first, our objective is to evaluate multiple hallucination detection methods. This way we can detect about the hallucination on the different purpose on the different AI. And the second, we compare the performance using statistical metrics. So we compare each metrics on each AI, so we can tell which one have hallucination or which one have no hallucination. And the third is identify the most reliable detection option. So we can find the most reliable AI, and we can find the most reliable detection that we can use to find the hallucination on the AI itself. And then four, we analyze performance difference across the datasets. So we analyze the difference between dataset number 1 and dataset number 2. Depends on the AI that we search on. And then next, we're going into methodologies. So for metrics, we use precision, source, recall, RLOC, and MCC. For the models, we use contradiction-based, retrieval-based, self-consistency, uncertainty-based, and internal state. As for the datasets, we use TrueFill QA, HelloEva, and lastly, FactScore.
Now we're going to get over here for the results, the yellow one for the internal state or neural network. Now overall we can see in each of these graphs such as the F1, ROC, MCC, performance heat map, precision, recall, accuracy. Overall, internal state or neural network has the best one overall. Also, next one of this is the confusion matrices. And as we can see, the ones with the highest numbers of false positive and false negatives in total belongs to self-consistency, while the least here belongs to, as I mentioned before, internal state or neural network. Now, in conclusion, internal state neural network is the model that performs the best overall, with its F1 score being 0.9829, being able to learn patterns from hidden states, with the worst performance being self-consistency. And also an additional one for the most economist or very large-scale usage, it is recommended to use the uncertainty-based, which is best for low resource settings. And that is all the information we have from our group. Thank you for listening, and we hope you have a pleasant day.